Okay, in this video, we're going to take a look at the product rule. In our last section about derivatives, we looked at how to take the derivative of the sum or a difference of two functions. And now we're going to look at how to take the derivative of the product of two functions. You can see here we have the product rule at the top of the page. Here's where we have two functions multiplied together, f of x times g of x. And to take the derivative of that product, we take the first function just as it is. Don't do any differentiating there. Just write it down as it is. Multiply that by the derivative of the second function. Then plus the second function as it is, no derivative there, times the derivative of the first function. I have to be honest, when I'm thinking about this, when I have this memorized and I'm using it, what's going on in my head is I'm writing out the derivative is the first, and what I mean there is the first factor times the derivative of the second plus the second times the derivative of the first. You're gonna have to commit this to memory. Okay, the product rule is something you'll see pretty frequently throughout the class. So here's an example of how we would apply it. Find the derivative of this function. And for this function, my first factor would be this part, underlined in blue, the 3x squared minus 4. And then the part that I call the second factor, the second part, that would be this part that I just underlined in green, 5 plus 2x to the fourth. So if we are asked to find the derivative of f, that is the first, write it down, don't change a thing, nothing fancy, just write down the first factor exactly as you see it, times the derivative of the second. So we have to take the derivative of the part underlined in green. The derivative of 5 is 0. The derivative of 2x to the fourth would be 2 times 4 is 8, x to the 1 less power. Okay, then we have a plus in the middle. Then we write down the second factor unchanged, write it just as you saw it in the original problem. And you need to multiply that by the derivative of the first factor. So now we need the derivative of 3x squared, which is 3 times 2 is 6, x to the 1 less power. The derivative of the minus 4, negative 4, is 0, because that's a constant. So there is our derivative. Okay, now we're not done yet. After you apply the product function, you should simplify in any way that you can. So we'll want to distribute in both of these spots. So we end up with 24 x squared times x cubed. Remember, you add those exponents. Minus 32x cubed. And we'll distribute back here too. We get plus 30x plus 12x to the fifth. And then in your final step, you'll want to make sure you combine any like terms. So right here we have an x to the fifth and an x to the fifth. So we get 36 x to the fifth minus 32 x cubed plus 30x. And that is our derivative of that original function that we had. Okay, let's try another one. Okay, again, you can see we have a first factor and a second factor. So we're going to apply the product rule. Here we need to do one little thing before we apply the product rule. We've seen this in our previous examples. When we have an x in the denominator like that, we can rewrite it as 2x to the negative 1 minus 1. And the rest just stays the same. I didn't do any differentiation there. I just rewrote the original function. Okay, so our derivative this time, dy dx. Remember, that's just another way to name a derivative. We write down the first factor as it is. Don't change it at all. Multiply it by the derivative of the second factor. Plus, write down the second factor. Multiply that by the derivative of the first factor. So 2 times negative 1 is negative 2, x to the 1 less power. And there's our derivative. Again, same thing as the last one. We'll then want to go ahead and simplify. So distribute in both places. Here we get 2 times 6 is 12. Remember, we add those exponents. So x to the negative first times x squared. That would end up being just plain old x, because 2 minus 1 minus 6x squared. Distribute back here too. That becomes a minus 4x and a plus 6x to the negative 2. Then, in our final step, we want to combine some like terms, and I'm also going to resolve that negative exponent. So our highest power is x squared. We have 12x minus 4x, so that leaves us with 8x plus 6 over x squared. There's our derivative for our second example. Okay, now that we've introduced this new product rule, we now have two differentiation rules that deal with products, the constant multiple rule and the product rule. So I want to make sure you understand when we need to apply each of those. The constant multiple rule is used only when one of the factors is a constant, okay? So look at this next example too, A and B. Look at the difference between these two. I have this 2 out front, and that is indeed a product, 2 times the quantity that comes next. But because that 2 is a constant function, it doesn't have a variable in it, we don't have to apply the product rule here. As opposed to part B, look, we have a 2x out front, that's the first factor, and we have an x cubed plus 4x, that's the second factor. Each one of those factors has variables in them, neither one is a constant, so we do need to apply the product rule here. So let's look at both of these. The first one, part A, dy dx. Remember that constant multiple rule says we just multiply by 2 and then differentiate what comes next. So we get 3x squared plus 4, taking the derivative of each one of those terms, because that's we can do that for a sum. And so our derivative here is just 6x squared plus 8. Okay, but in this next example, it's not quite that easy. We need to apply the product rule. So here, dy dx. So we write down the first factor, multiply it by the derivative of the second, write down the second factor, multiply it by the derivative of the first. And then we'll go ahead and distribute. And combine your like terms. 6 plus 2 is 8x cubed. 8 plus 8 is 16x. And there is our derivative for part B. Okay, so just make sure you can recognize when you need to use the product rule in part B and when you don't need to in an example like part A. Just a couple more examples. Again, this type of problem, example 3, you're going to see this in all kinds of different sections that we have, just applying different rules. Find the equation of the tangent line to the graph of h of x at the point -2, -6. Okay, so remember these directions, find the equation of the tangent line. In order to find the equation of a line, we need to find the slope of that line. And we find the slope by taking the derivative. So that's what we'll need to do first here. Okay, our first factor and our second factor. So we apply that product rule. First factor times the derivative of the second factor plus that second factor times the derivative of the first factor. There we go, that's our derivative. Let's go ahead and simplify again by distributing. I have to be careful when we distribute here, we're actually going to need to FOIL, okay, multiply this out. So we end up with 3x to the 4th minus 3x squared minus 3x squared plus 3. And then distributing here at the end, we get 2x to the 4th minus 6x squared. And then when we want to go ahead and gather up any like terms, let's see what we have going on here. Here's to the 4th, there's to the 4th, so we end up with 5x to the 4th. Nothing cubed. Here we go is squared, squared, and squared. So -3 minus 3 minus 6 leaves us with 6, 12. Minus 12x squared, and then we just have that plus 3. Okay, now we're not done. That's not what they're asking for in this question. They're asking for the equation of the tangent line at the point -2, -6. So into that derivative, we need to plug in the x value, which is -2. And that's going to give us the slope that we're looking for. Okay, you can do that in your head, or you can grab your calculator. But either way, it should come out to be 35 for your slope. So here's our slope, and here's our point. Remember, you can use point slope form or slope intercept form. I'm just going to do it one way this time, just with point slope, because I'm running out of room a little bit here. So y minus a negative 6 equals 35 times x minus a negative 2. Go ahead and distribute that 35. Subtract 6 from both sides. And there is the equation of our tangent line. One thing that I just want to show you real quick, if we pull up Desmos and look at the graph that goes with that problem, just so you can see what's going on here. Our original function that they gave us in the problem was x squared minus 1 times x cubed minus 3x. Okay, well, that's a nice funky little polynomial there, all kinds of curves in it. And they asked us to find the tangent line at the point -2, -6. Okay, so there's our point, that black dot. And let's see what our tangent line looks like. See if it comes out looking right. There we go. That red line is our tangent line. So you can see it would be really hard to draw that by hand because to just touch at that point, it's really steep right there. But you can see the picture of what we just calculated in that problem. Okay, our last example in this section. Okay, this time instead of giving us some equations, they just gave us some basically ordered pairs, right? That's what these are. So for the function g, when x equals 3, y is positive 1. For the derivative of g, g prime, when x is 3, the y value is -4, and then we have values for the h function also. And they are asking us for each of these, for part A and part B, our goal is to find f prime of 3. So we need the derivative, and then we're going to plug in 3 for x. So they give us f of x. To find the derivative, we are going to apply our differentiation rules, even though this looks a little different than the functions we've been working with so far. We still apply the same rules. 5 is a constant, so the derivative of 5 is 0. G of x is just going to be, rather than actually calculating the derivative, we're just going to label it g prime of x. Okay, and remember, our goal was to find f prime of 3. So 0 goes away, minus g prime of 3. So all we have to do is look up in our little table here. G prime of 3 was -4, so we get minus a -4, which is +4. That's what we're looking for part A. For part B, we need to apply our new product rule that we just learned in this section, because look, f of x is defined as the product of g of x and h of x. So here our derivative is, and we're basically just writing out the product rule itself. We don't really have to do any work here. First times the derivative of the second plus the second times the derivative of the first. Okay, and then remember, our goal is to find f prime of 3. So I'm just going to go ahead and plug in the numbers rather than writing that all out again. G of 3 is 1. Look it up here up at the top. H prime of 3 is 2. Plus h of 3 is -3. And g prime of 3 is, again, -4. So then we just have to do the arithmetic. We get 2 plus 12, which is 14. Okay, hopefully those examples help you out with the product rule.